Okay, welcome. Thank you for coming. We're going to talk about the flatbed printer and basically double-sided printing and also dual technology, which is using the laser cutter and laser raster embossing with the flatbed printing as later. Um, the flatbed printer is located at FAM Hall. My name is Pedro Ramos. I work with the flatbed printer along with Hank Woodward. Is with me today. And we take care of all the projects for the flatbed printer. As an introduction to the machine, it's a printer with a capacity to print on many different substrates and materials. It uses 4 color process inks plus gloss varnish and white, which can give you the chance to produce a lot of effects and interesting textures and on different surfaces and materials. I will explain a little bit the color model of the printer. Again, it uses cyan, magenta, yellow, and black, which is what you guys probably are used to with any printer on paper. But since the printer is designed to print on substrates other than white paper, it also has white ink to compensate for that. And it has a gloss varnish that can give textures and special effects as well as coating. That was what the previous session this morning was dealing with. The inks are cured instantly using ultraviolet light, and that allows to lay multiple layers of ink over the material. Since we don't have to wait for one layer to dry to apply the next layer, that can result in application of inks in layers and creating elevation and texture over the material, and that's usually achieved with the gloss varnish. Also, I have to mention that for this term, since we're operating online pretty much, the materials that are available for the printer are limited, and these are the materials that we have available: clear acrylic, we have wire acrylic, we have chipboard, and MDF. You can select from this list of materials depending on your project or your design, and select the most appropriate one. I gave an example early this morning. If you, for example, you have an idea of how to design a phone case, you will not be able to actually print a phone case, but you can design the image of the phone case and print it on top of acrylic material, and that would give you a useful academic experience and also a feedback of the results, like on the material and the printer features. Also, for this term, we have a limited set of sizes available. The sizes are listed there, and all this information can be also found in a website at the end of the presentation. And I'll give you the link to the location. And we can also post that on the text box of this presentation later. Okay, so we're going to be presenting today double-sided projects and dual technology projects, which are projects that include laser cutting and rastering. And double-sided because it's a little bit more advanced than the regular prints. We spoke this morning about the different inks and how you can use white to create layers and all that, but that's talking about just one side of the material. For double-sided, there are some considerations that we have to take, and we're going to discuss these things in detail. Okay, one of the concepts that needs to be understood when approaching a multiple-sided project is what is the intended view and direction of the project. Um, you could have a project that is double-sided on opaque material, and in that case, you would print two separate images on two sides of the material. So it could be like a postcard or like a business card. You could have the two sides printed, and each image is going to be completely different to the other one. But also you can print on semi-translucent or translucent materials like acrylic. So in that case, you have to determine what do you want to do with your design, because in theory you could create a design that is viewable for both sides or only one side. So depending on that, you have to plan your layers and the order of printing of the material accordingly. For example, we have this illustration here, and that was for a project that simulated stained glass. And if you notice, this would represent the material, the acrylic, and the back layers print in reverse order and will print on the back of the material. And in this case, we're using one layer of CMYK, which is the color process image, which will print first on the back of the material, and then another layer with white ink, which will give it a backing for color accuracy, and also it will block the transparency of the ink. After you're done with that, you would have to flip the material, like rotate it, like flip it, and then print the rest of the image on the opposite side. This operation, we have to be careful when we do this operation, because we want the elements on the front to register perfectly with the elements in the back. So what we usually do is we print a template on the bed of the machine, and then we flip the material exactly matching or registering with that template. So let's go to Illustrator and show you some of the details of this. Okay. I don't know if you have had a chance to visit the website and download the templates. If you're interested in the flatbed, I highly recommend you to do so. This is the template for any projects, simple projects, or also double-sided projects. The way the layers are specified can be seen here on the layers palette. The only difference from simple projects in just one side is that we prepend the word back or front, depending on if the layer is intended to be printed on the back or the front. I mentioned before that there's a flipping of the image involved. We take care of the flipping, but we ask you to indicate the direction of flipping in your order form. In this case, when you design, usually the order, okay, give me 1 second here. Yeah, when you're designing the material, if it is intended to be viewed from one side, and if it's transparent acrylic, usually you want all the layers in the order that is going to be viewed for designing purposes. However, we ask you that before submitting the project to us, you would have to physically move the layers, in particular the back layers, and place them in the order they will be printed. In this case, this is already in that order, and it works because it's going to be viewed from one direction. However, there could be projects where your intention cannot be easily interpreted by us. So we need you to specify the order of the layers in the order it's going to be printed in the material. Imagine the material as a sandwich. Let me try to show this one moment. So this is that print. It has layers of ink in the top, and it also has layers that were printed in the back, and then they were sealed by one final layer of white backing. So the only way we can avoid confusion is that even though you might want to order the layers for design purposes in one direction, when you submit the work, we need the layers to be specified exactly in the same order that they are going to be printed. And you might consider the material as the borderline between the layers that say front and the layers that say back. I don't know if this is making sense. Let me go back to the Illustrator so we can. Is Illustrator being shared? Yeah. Okay, so the back layers, when we receive your project, we are going to flip that image, print it in reverse, because it's intended to be viewed from the front of the material. And then we're going to print them exactly in the order that they are here. So if your design requires for you, while you're working, designs for you to have the layers in a different order, work like that while you're developing the project. But when you submit to us, the order has to be specifically in the order that it has to be printed. But the order is from bottom to the top. So in this case, it's the viewing of the material once the file has been prepped for us is not ideal for design, but we will understand that your intention is that we print first from bottom to top. First, we will print the CMYK, and then we will print the white ink for sealing. And that is exactly what happened here. We have the CMYK first against the material, and then the white for backing. And then we will flip the material and then print the front side. And then we will do the rest of the layers, the front clear ink and the front white ink, which is the one that gives the detail of the embossing. Let me go back to the slides. Okay, so these are the illustration that I showed previously to indicate the layers. This was the result of that job. As you can see, there are elements in the back that are viewed through the material, and then other elements in the front. And then I also like to show off this one. It's kind of recent, but it's the same situation. Some elements in the front, some elements in the back. The elements in the back have to be flipped and printed in the reverse order because the intended viewing position is from front to back. Okay. When you fill out the form to submit the project, another thing that's important to know is, I mean, there is checkbox to select the flipping orientation of the material. The usual form is horizontal flipping, which is along the vertical axis. That would be an easy way to imagine it is as a magazine or a book page. If you were to flip this, it's along the vertical axis and it's the same image. What is on top is also on top and the back. Occasionally there are projects, usually not when it's transparent, but when material is opaque, there are situations where the image has to be flipped vertically. So we use the reminder of a coin flip, because if you notice all the coins, when you flip them vertically, they are upright on the opposite side. If you're looking at Lincoln, Abraham Lincoln and the penny, it's in the front, upright, and then you flip it and you will see the building in the back upright. So this is something to notice and to indicate when you submit the form. This project also falls in the laser cutting category. It's a dual technology, but I also want to mention the idea of the template and the flipping direction. These were like small chips, like for a toy or like a puzzle. They were printed in both sides, on both sides, the same colors, same image, the replica. But if you notice, all of them are symmetric, and they all have an axis of symmetry. So in this case, each one of those figurines had to be flipped along the axis of symmetry, so the image would reflect the other side. Actually, I remember in this project, there was one in particular that was not symmetric, and that piece failed. It did not work as intended. But most importantly, the idea of the template that we print on the flatbed for all the double-sided prints, because we need to be very careful when registering elements from one side to the other. This is more of a dual technology project. This is with the laser. Give me just 1 second. Yeah. Okay, let's move on to the dual technology. When you plan to use laser cutting or rastering effects with the laser and flatbed printing, the process used to be that students would submit a laser cutting project first. They would pick it up and then they would bring it to the laser printing, and then we would take care of the printing. Since we're operating online only, the only way to make this possible is for us to take care of the laser cutting part of the projects. So for that reason, we are offering now a template for dual technology online that you can download on the website. And that template includes all the layers necessary to organize this, a project for those two technologies. Another thing that I have to mention is that do not jump right away to try to do a project like this from scratch. We ask you to be familiar with laser cutting. We are not the laser cutter operators. We're just trying to facilitate a way to accomplish the goal of submitting a complex project. But we need you to be familiar with the procedures, and they have information online, and they have presented seminars and all that, so that everyone is familiar with the laser part of the technology, so the whole process can be successful. There are things you're supposed to know from laser cutting before you can merge the two projects. Let's go to the Illustrator. Okay, so when you download the dual technology template, you will notice that there is a lot of information to the left side that encompasses both technologies and all the required steps. We have taken, we have worked to include all these swatches here that are used for laser technology, and also the swatches that are used for flatbed printing. You just have to, with the eyedropper, select from these colors, and it should color your objects appropriately. But again, you should be familiar with the laser part of the story. The first thing you will notice when you open the template, when it's blank, you will see that for dual technology, all the sizes are included there. We have these margins, and you would have to select the size that you want to print from these dimensions. And then the way to proceed is to rename the layer, the label of the size with your name before submitting. So in this case, the student renamed the size of the project here. When we print this, we will print and cut at the size that is required for the project. Also, let's go to the layers. If you notice the layers that are shown here, there are laser layers and there are flatbed layers. And these could, we're talking about dual technology here, but this could also increase in complexity by adding front and back sides. So you could have like all these layers for clear ink, white ink, CMYK, etc. But you could also have like front and back. And then on laser processes, they could be front and back as well. We do not recommend excessive raster processes and to be done on material, because the material has a tendency to warp, because laser works hot and it will curve and warp. And then when we bring the material to print over the laser printer, it becomes a nightmare. So we usually recommend for people not to use raster processes over all the surfaces. If you notice this file, this is well done because it's not rasterizing the entire surface of the material. There are white areas, and that gives the material some time to cool off in the process. Also, if you notice, there are gray areas and black areas. The black areas the laser will hit it with maximum power, and the gray areas will be diminished accordingly. So that creates a difference of effect. So paying attention here, you will see that this project has no vector processes, but it has a raster process on only one surface. And then if we notice the flatbed layers, starting from the bottom, we have clear ink first, then white ink, then the CMYK on top of that, and then clear ink on top. Okay, let me return to. So I believe I have a picture of that project. Yep, this is the final result of that project. As you can see in this area, there are some raster indentations, and there's also gloss texture. Okay, here's a clip of the laser machine cutting a piece. It could be. The reason we print after we laser cut is because laser on certain materials, it will burn the surface a little bit. So once you are done with the laser cutting and you know where those marks are, you can apply ink, maybe multiple passes of white ink or something similar to cover those defects. Ideally, the material should be inspected and prepped before submitting, because that way we can avoid problems with the. That's the final result of that laser cutting and then the printing. And I believe I have the file here too. So this was printed only on top. Yep, it's here. Am I sharing Illustrator? Yep, okay. So if you notice, the laser layers only include the vector process, which is for cutting. And then on the flatbed layers, we have, white ink, CMYK, and then embossing, clear ink on top of the material. Here's another sample. This was rasterized with the laser on top, and then similar image was printed on the back of the material. Another consideration for rastering processes and with the laser, I think I mentioned this already, but if you are going to use an image like this, like texture, it would be high contrast. It would have to be high contrast. It is desirable to have elements that are white, entirely white, because that would be elements or sections that won't be touched by the laser. So it helps control the heat of the material, of the surface. And it also enhances the texture. It looks much better. This is valid for both the laser processes and also when you're doing textures with the flatbed printer using the embossing feature. High contrast is always better because it gives you more definition. Here's a picture that I thought might be interesting to see. This was a class submission. Multiple students submitted projects. So we took care of, since we're doing the laser as well, we gang ground the entire class submission. So we did all the laser processes at the same time. And then the flatbed printing, sometimes it can be done at the same time, but it all depends on the layer specifications. If it's too different from one job to the other, then they would have to be run individually. Again, I don't know if you can tell from this picture. It's hard to figure out what it is. It is one piece of acrylic that has been rasterized over the entire surface. And you can tell that it's warped. These are the edges. Like this is a side view, and this is like a 45-degree view. And it's almost like, I don't know, like a quarter of an inch separated from the table. This becomes a nightmare because the flatbed printer focuses on the surface, and if we have warped material like this, we have two choices: either force the material to stick to the table, which is also dangerous because the material is strong enough to like rip the tapes apart and pop back out, or focus the printer at the highest point of the material, which would also result in a very blurry print, and that's probably not what you guys want. Okay, so I guess we'll open for questions. I always show this slide. If you only take one piece of information from this presentation, is this URL, so you can go to the website, and we have some information posted there, and it's a good idea to go through it. And there's also information on how to process submission, which is going to be done through the Blackboard portal and through the professor. But that is all explained there, and so you can. Over there as well are all the templates that I showed today, and also the submission forms. So if you have any questions, just unmute and go ahead.
One moment, we're trying to finish reading all the things that he posted in the chat.
Okay. Oh, Hank has been busy.
Sorry. Yeah, I was just sharing links along as Pedro was talking through different subjects to kind of just show where more of that information is accessible. There are risks, like when you combine both laser and flatbed processes. The biggest one is a raster process for laser cutting. Pedro was just detailing and showing like the warping of the material. That is very, very common with plastics. And sometimes like we're just not able to counteract that warping. And that just means that we won't actually be able to run the print successfully, right? If we did still try to force the printer to run, if that material were to pop off the table or pop back up into that curved state, we'd end up damaging the printer, and then we wouldn't be able to run any projects for anyone else, right? So sometimes we want to facilitate your work as best as possible, but there are some considerations for machine safety and continued successful output of other people's work. So there might be some cases where we might end up having to email you or let you know that there's a problem, or we might not be able to run things exactly the way you were hoping to. But we'll be open for discussion on that via email. And again, this is the email address that you can correspond with us. It's scadlab@scad.edu.
Yeah. One thing that I wanted to mention is that both things, double-sided printing and dual technology, are very complex subjects, and we could be talking for hours about either one of those. And these two are like crammed into one session of 30 minutes, which is kind of short. But again, we are there, and if you have questions, once you have read all the material and downloaded the templates and you start working on the project, you will start to encounter like questions or doubts. So we are there for you guys. You can email and contact us, and we'll do our best to help you figure out the project.
If I can say one more thing. So, this is like a really advanced techniques with the flatbed. So we really recommend like starting with a couple simpler projects, getting an idea of what you do in the file and how that translates to the printed result before moving on to double-sided or even working the laser into your projects. It can lead to some really, really fascinating results. But try to get familiar with all the basics first, right? We, across all the technologies, we always strongly recommend sampling and testing before you do your final project. The flatbed is an incredibly experimental machine. The way we use it is unlike anywhere else in industry. So, you know, we always see such like wonderful and exciting projects from you all. And we want to help facilitate all of that, but it's good to start with like to with simpler projects to get a better idea of how things work and what you're doing in the file and how that renders. But then when you've got like a big complicated project or you're after a very specific result, both Pedro and I are great to talk to you about all of that, to iron out the details and the specifics. Yes. Yes. Mhm. Okay. Megan, did you have any questions following what was typed out in chat?
No, you've been very thorough. Thank you.
Great.
Okay.
All right. So I guess we can wrap this up. Thank you for coming.
Thank you for hosting.